if we try to plug in a 0, of course we get this first thing is 1 over 0. The second one's 1 over 0. You know, it's kind of like what's going on. It's almost like an infinity minus infinity. That's gibberish, okay? First of all, it's not infinity because coming from the positive side, these both give you positive infinities, but coming to 0 from the negative side, they both give you negative infinities. So kind of goofy, you know, don't just say, oh, it must be 0, which it could be, but we've got to make sure that we do this using proper techniques here. So what we're going to do is rewrite this with a common denominator so we can actually do the subtraction. So this first one we're going to have to multiply by sine x over sine x. So we'll have sine of x times 1 on the top and x times sine x on the bottom. And in a similar fashion, the second term we're going to multiply by x over x. So we'll have x times 1 on the top and x sine x on the bottom. So common denominator, we can go ahead and do the subtraction. So we'll have a sine x minus x all over x sine x. Okay, so now as you try to plug in a 0, we do in fact get 0 over 0. And of course the nice thing about getting this 0 over 0 is we can use L'Hopital's rule. Okay, so I guess I'll switch to red using L'Hopital's rule here. We're going to have our limit as x goes to 0. Derivative of the numerator. Well, you know, derivative of sine will be cosine, and derivative of x is 1. Denominator, we're going to have a product rule. So derivative of the first term times the second plus the first term times the derivative of the second. Okay. Now if we try to plug in 0, we can see that the cosine of 0 is 1, so we get a 1 minus 1 on the top. So that top part is going to 0, and plugging 0 in the denominator, you see that that's also going to 0. So once again we have 0 over 0, which means what do? Well, it means we can use L'Hopital's rule again is what it means. Okay, so let's use L'Hopital's rule a second time. L'Hopital, the limit as x goes to 0. Derivative of cosine is negative sine of x, and the derivative of 1 is 0. And our denominator, we have sine, so it's derivative. And here we've got to go again, product rule. So derivative of x is 1 times cosine of x plus the derivative of cosine, I guess that's negative sine, times x. Okay. So just simplifying this, limit as x goes to 0 of negative sine x. Denominator, we've got a cosine x plus cosine x. That would be 2 cosine x minus sine x times x. I'm going to write it as x sine x. Now let's try to plug in the 0. Numerator, sine is going to 0. Denominator, plug in the 0. Cosine is going to 1. So we'll have 2 times 1, and the second term is going to 0. So the denominator is going to 2. So if that's the case, we've got a 0 on the top, a 2 on the bottom. That's not a L'Hopital's rule form. That means we're actually done because 0 over 2 is 0.